Hey folks, so welcome to another lesson. Now, this lesson should be fairly straightforward and easy for those of you who have done any kind of physics before in third year. It's just a revision lesson on resistance and, pardon me, applying Ohm's law. There is a wee new bit here at the end about temperature and resistance, which we'll look at. But in general, you should be able to blast through this fairly quickly, folks. Okay, so first of all, a wee reminder about the circuit's rules because you really need to remember these for later on because we're going to be using these along with Ohm's law in much more complicated questions. So make sure you understand what the circuit rules for series and parallel circuits are. You should know these off by heart. So very quickly, series circuit, voltage splits up or the individual voltages will add up to the supply voltage. Current remains constant, and you kind of know a rule for adding resistors in series, but we'll come back to that again later on. How do you know a circuit is in series? There's only one path to go around the circuit. The parallel circuit rules, a quick way to remember them is that they're the opposite of the series circuit rules. So I wouldn't bother remembering what the parallel circuit rules are. Just remember what the series circuit rules are, and then to get the parallel one, you're doing the opposite. So in series, if voltage splits up, in parallel, it's constant. In series, if current is constant, then in parallel, the current splits up. And then in series, if there's only one path for the circuit to go, the current to go round, in parallel, there's two or more paths for the current to go round. Okay, so that's my top tip for series and parallel circuit rules. So resistance, what's the definition of it, is how difficult it is for current to flow around a circuit. It's measured in ohms, and remember, this is the symbol for ohms, it's the Greek letter omega. There are several different types of ways of drawing resistors. You can draw them as a rectangular block, or you can draw them as this kind of wee zigzag. This one is the American symbol, and this is the more international symbol. And this is for a fixed resistor, which means the resistance doesn't change. So if it's 10 ohms, it always stays as 10 ohms. A potentiometer, this is another way to draw a variable resistor. Now, if you think about the definition of voltage is really the potential difference, so you can understand where this name potentiometer might come from. And then finally, this is the variable resistor symbol that you're more familiar with. We'll tend to use this one for the majority, but we will come to use this one when we come to do sensor circuits in electronics. So just so that you've seen this before we come to it, folks. Okay, normally I demo resistance in a conductor and show you what happens. Essentially, if you put a big enough current through a resistor, you can cause it to melt, and that's how a fuse works, is that if you put too high a current in the fuse, it will cause the fuse to melt and break the circuit, so it stops the circuit from working. Key thing you need to know is that if you increase the temperature, the resistance will increase. If you increase the resistance, the temperature will increase. Okay, and this is how we can use electricity to give us cooking, because it's a heating element, or as a heater. So these things will tend to use very high currents because it's that high current which then gets converted into heat energy. So for example, the cooker, if you've got an electric cooker at home, that will run off 30 amps. That's the highest rated current in your circuit at home. Another way you can remember this is that light bulbs, these filament bulbs, if you leave them for a very long time, then they will get incredibly hot. Remember using the ray boxes, and that's because a lot of the electrical current is being converted into heat energy as much as it's being converted into light energy. So this is something you just need to remember. Increasing temperature increases the resistance. And we're going to come back to this later on when we do the experiment on Ohm's law. Okay, Ohm's law, as you hopefully remember, is just V is equal to IR, and it has these units here. Remember our KFC technique, know it, find it, calculate it. So here's a worked example. A pupil uses the following to measure the resistance of an unknown resistor. The voltmeter measures 6 volts and the ammeter measures 2 milliamps. What's the resistance? So hopefully you can do this yourself. So if you're confident, just pause it and try it yourself. If you're not sure, follow the video and I'm going to take you through the answer. So remember, we're using our KFC technique: know it, find it, and calculate it. So know it means we know what we've got from the question. So we know we've got 6 volts here, and we know that the current is 2 milliamps. Now this is where our numeracy comes in, because remember, we don't want it in milliamps, we want it in amps. So this is one good thing about doing the KFC technique, is it allows you to check if the units are correct. So 2 milliamps isn't what we want it in, we want it in amps. So remember, milli is the same as writing 2 times 10 to the minus 3. Okay, and remember your units. You can leave it like this, or if you want, you can remember that milli also means divide by 1,000. So either one is correct. You can write it as 2 times 10 to the minus 3 or 0.02 amps. Either of these are correct. It's up to you which one you want to use. And then we want to find the resistance. So we write that down and put a question mark next to it. Okay, exam technique now. We know what we've got and what we're looking for. So we look at our relationship sheet and we find the only equation we can use is this one here. So write it down, because that gives you your first mark. So that's 1 mark out of 3. You then substitute in your values. That will give you your second mark. Don't bother rearranging the equation, because that might lead to a mistake, which means you would lose a mark. So put in your numbers first of all. And then that's you got your second mark. And then the final mark is really just for doing the calculation and writing down the right answer. So it would be 6 over 0.02. Okay, and if my maths is correct, that should give me an answer of 3,000 ohms. Okay, and remember to put your units in at the end, folks. Yeah, and that's it. Okay, so practice makes perfect. So what I want to do is the questions which I'm going to upload for you to do are here, and a wee reminder for you that mains voltage is 230 volts AC, and that 1 microamp is the same as 1 times 10 to the minus 6 amps, or 1 milliamp is the same as 1 times 10 to the minus 3 amps. So remember, if you see the M, replace it with 10 to the minus 3. You've practiced this before, you should be able to do this fairly straightforwardly. To give you even more practice, folks, I want to try the question from the textbook, chapter 1.34, questions 1 to 5, and this is how you find the login page, and that's the username. So practice, practice. I know it's going to be easy for some of you, but it's good to get into the habit of it, because we're going to do lots more complicated stuff later on. Okay?